This video goes over how to find, problem solve when you're doing applications of right-angled triangles. So the first two terms that you need to be familiar with are the angles of elevation and depression. So the angle of elevation is measured from the horizontal up to an object. The angle of elevation is measured from the horizontal down. So this is the angle of depression, and it's measured from the horizontal down. So these terms show up in word problems, and you need to be able to put them into the appropriate place in the triangle. So the first example here, from the top of a fire tower, the angle of depression of a forest fire is 27 degrees. Find the distance from the tower to the fire if the tower is 175 meters high. So I'm going to draw a sketch here. I've got angle of depression, so I know I need the horizontal. And then I'm going to draw, I've got a forest fire over here. So this is my point F. I'll use here for T, and then P. Okay. So my angle of depression of a forest fire is 27 degrees, so that is from the horizontal down. This angle right here is 27. Because these lines are parallel, and I've got a line connecting them here, I've got a Z, and in that Z, the angles in the corner are actually equal to each other. The other piece of information that I know is that the tower is 175 meters high, and I know that I'm looking for the distance from the tower to the fire. So I'm going to say let D represent the distance from the tower to the fire. So what I need to do is I'm going to solve for D. I've got a right-angled triangle. Just like I was doing in my problem solving, I'm going to label my sides. I've got my opposite side, my hypotenuse, and then my adjacent. So this is going to tell me that the ratio that I need to use is my tan ratio. So tan 27 is equal to my opposite side over my adjacent side. I'm going to switch those two as my shortcut to solve. And now I'm at a point where I can input those on my calculator and find out that the distance is approximately 343.5 meters from the fire and the tower. The next example here is using the angle of elevation. So the angle of elevation to a plane in the sky is 25 degrees. So that is from the horizontal up to the plane. So I've got 25 degrees, and I've got a plane right here. So I use P for plane, G for ground here, and then T. So if the horizontal distance from the person to the plane is 2,500 meters, that's right here, I'm looking for H. So we'll let H represent the height of the plane. So I have an angle. I'm going to label my sides. I have my opposite, my hypotenuse, and my adjacent. Here I'm going to use my tan ratio again. Opposite over adjacent in order to solve for my missing side, multiplying both sides by 2,500 and evaluating that on my calculator is going to tell me that the plane is 1,165.8 meters above the ground. Our last example in this video deals with two right-angled triangles. So from a point on level ground, the angle of the top of the CN tower is measured and found to be 31 degrees. So I've got my CN tower here, ish, and I'm going to measure that angle, and it's 31 degrees. Then I'm going to move 130 meters closer, so that means this distance, just use A, B, C, and D. The angle of elevation is now 35 degrees, but I want to look for T here. So let T represent the height of my tower. And now I've got a problem. Really what I'd like to do is use either of my right angled triangles to set it up, but because I don't know what this length is here, x, I'm not able to find my T value right away. So let's start by using my big triangle. So this one here. And I'm going to set up a ratio that involves what I know. So T is my opposite. This side here is 130 plus x. That's my whole side length down there. And I can write my tan ratio as tan 31 is equal to my opposite over my hypotenuse. Great. So now I'm going to use my smaller triangle and I'm going to write another tan ratio. So my sides are the same, my T is still my opposite, and now I've got x as my adjacent here. So I also know that tan 35 is equal to T over x. So now what you should notice here is that I've got two equations and two unknowns. I can rearrange my blue equation to get x in terms of T, which is going to allow me, so I've got 1, 2, to substitute in and solve. So I'm going to sub equation 2 into equation 1. I'll switch back to my black pen. And I've got tan 31 is, let's multiply out here so I don't have the fraction. Tan 31 times 130 plus x is going to be equal to T. And now I'm going to take this expression that I have for x and put it into my equation. So tan 31 is 130 plus T over tan 35 is equal to T. Now I want to get my terms that all have T onto one side, so I'm going to do some expanding. 130 times tan 31, which is just a number, so you could evaluate that on your calculator. I'm just leaving it in so I don't have to write all the decimals. Tan 31, tan 35, T, and I've got T on this side too. So now what I'm going to move is move my tan 31 over tan 35 T onto the right hand side. And then what I'm going to get is that T minus tan 31 over tan 35 T is equal to 130 tan 31. Now I'm going to keep going here and I'm actually going to factor out T, and I'm going to get T times 1 minus tan 31 over tan 35, which is just a number, is equal to 130 times tan 31. Now what I can do here is I'm going to take this value and divide both sides by that value to get my answer for T. So I've got 130 tan 31, and then I'm going to divide by 1 minus tan 31 over 35. You can do it in steps if you want to make sure that you're getting all the right values. And you should find that the height of the tower is 550.5 meters. The actual height of the CN Tower is about 553.